Hi everyone, welcome back. In this video or series of videos, we're going to look at inverse functions and what they are, how do we find them, what are some properties of them. Okay, so let's just jump straight into it. So an inverse function is a function which undoes the operations performed by some original function. Okay, and that's typically the definition of inverse that you'll see throughout the rest of your time doing maths. Okay, an inverse of something is just something that you do to undo something else. Okay, so the inverse of addition would be subtraction. The inverse of multiplication would be division. The inverse of a square would be a square root. Okay, so an inverse is just something that undoes something else. And for functions, we're talking about a function that undoes some other function. Okay, and we'll see an example of what that means in a second. But for something basic, let's say we've got a function f of x equals 2x. Okay, that just means multiply whatever x value you have by 2. Okay, well, how do you undo something like that? Well, if I start with, say, the number 3, and I multiply it by 2, excuse me, start with 3, multiply it by 2, we get 6. What can I do to 6 to get back my original 3? Well, I can divide it by 2. Okay, so it would seem that dividing it by 2 would be the inverse operation. So that would mean this function here, g of x equals x divided by 2, would be the inverse of f of x equals 2x, because you undo this multiplication of 2 by dividing by 2 in this function here. Okay? So we say that g of x is the inverse function of f of x, because whatever you put into f of x, you can undo that by putting that f of x value into g of x. Okay? Now, if an inverse exists, okay, if we are able to find an inverse, sometimes you won't be able to find one, but if we are able to find one, then we give it a special name. We call it, well, if the original function had a name of f, we call the inverse of f superscript -1. I'm not going to say f to the power of -1 because that has different connotations. Okay, it does not mean that we divide 1 by f. Okay, you typically have seen x to the power of -1 be equal to 1 over x. Okay, that's not what this means. Okay, the -1 there tells us that it is an inverse function. Okay, it's not necessarily going to be 1 divided by something. All right, so that's not what it means. Whoops. It's not what it means. All right, let's look at another example. Okay, here I've got f of x equals 3 times x minus 2. Okay, so what that means is I start with an x value, I throw it into my function f, and my function does a whole bunch of stuff to it. Okay, think of function like a machine. Okay, you give an input to a machine, the machine does something special to the input and gives you something else at the end. Okay, in this case, if I put x into my function, first what my function does is multiplies that x by 3. Then in the next step of the process, it will then subtract 2 from that number. Okay, so we start with x, multiply it by 3, subtract 2 from that. The inverse function would have to undo all of those steps one at a time, starting from the last step that was performed. Okay, so if I had a last step of subtract 2, then the first step for my inverse function would have to be to add 2. Okay, and that's indicated by what's going on up here in the numerator. So I give some input x, and to undo this subtraction by 2, which was the last step of our function f, I then have to add 2. Okay, then in the next step of my inverse function, I would have to undo this multiplication by 3, which in this case would be to divide by 3. Okay, so you can see that we're just undoing each of the steps performed by the function f one at a time in reverse order, and that should give you your inverse function. All right, another way to look at it is like this. Okay, so again, we've got to think of this function f like a machine. The machine takes an input, it does a whole bunch of stuff to the input and spits out something else at the end. Okay, so for this function machine f, we take an input x. Then, according to our function rule, we then multiply that x by 3. Then we do the 3x and then we subtract 2 from that, leaving us with 3x minus 2. And then we spit out that number as a final value. And we say that the function is equal to 3 times the x value minus 2. Okay? With our inverse, we're going to have to do things in reverse order, undoing steps one by one. So for our inverse function, we're going to take an input. And first thing we have to undo is this last step here, subtracting 2. And to undo that, we add 2. Okay, because subtraction and addition are inverses of one another. Then we've undone this step. Now we have to undo the multiplication by 3, which for us means to divide it by 3. Divide all of this stuff here by 3. Okay, that gives us this. So we've undone this step. And now that we've undone all the steps in our original function, this quantity here is now the final value for our inverse. Okay. Now, those of you who have read ahead and sort of already know what's going on, you might be able to see a connection between this and this in the way that you might be able to find a way that we can get this inverse function from this with a very formalized process. And we'll see that in another video. For now, this is all you're going to think about what the inverse is, okay? The inverse is just the function that undoes all the stuff that the original function did, okay? Now, what that means is if I take a particular value of x, so let's just pick a number. Let's say we use 3, okay? So let's say I input 3 into my original function, okay? The next step of my function will be to multiply it by 3, so that would give us 9. And then the next step would be to subtract 2, which would give us 7. So the final value that this function is spitting out is 7. And so the way that we can write that down is f of 3 equals 7, okay? What I'm going to do is I'm going to take this final value of our function f, and I'm going to put it as our input for our inverse. I'm going to see what happens. Okay, if you think about the inverse as being something that undoes a whole bunch of stuff, you should realize that the thing that we get at the end of our inverse should be the original number that we put into our function. Let's see if that's the case. So if I put 7 into my inverse, okay, say x is 7, I'm going to add 2 to this number. So 7 plus 2 gives me 9. And then I'm going to divide all of that by 3. So 9 divided by 3 is 3. Aha. And it spits out a final value of 3. So we say that the inverse of 7 equals 3. Okay? And what's interesting, you can do that with any number you like. It'll always turn out that way. Okay? If you put a number into your function, you get the value of the function at that number, and then you put that number into your inverse, you will always get your original number back. Okay? Now this 7 here, I mean, we've already said that f of 3 equals 7. Okay? So I can replace this 7 with f of 3 because I know f of 3 equals 7. And we already know that we're going to get an answer of 3 at the end. So look at this magic that happens here. We do the inverse of our original function of some number. It gives that number back. Okay? And what you can do is replace that number with anything you like. We can replace it with the number 1. It'll give me 1 back. Okay, I can replace it with negative 12. And it'll give me negative 12 back. Okay? So long as your function, your original function is 1 to 1, that is, there is only one y value for each x value, and only one x value for each y value as well, we can just write it like this. F dash, or your inverse function of f of x, will just give you x. Okay, whatever you put in at the beginning here, you work through your function, you get some number here, you put that number into your inverse, it'll give you your original number back. Okay, and we can sum all of that up in this statement here. Okay, so that's what your inverse does. All right, and this picture just sort of shows you exactly what I did. Okay, we start off with an input x, I run it through my function f, I get f of x as an output. taking this f of x value, I'm now going to put it into my inverse function. My inverse function undoes everything that my original function did and spits out my original input of x. Okay, so that's what an inverse function does. That's how your inverse function is related to your original function. Okay. Now, it's really important to understand this first dot point here, okay? Only one-to-one functions have an inverse. So let me give you an example of a function that is not one-to-one, is many-to-one. This is f of x equals x squared, okay? Now, let's assume that a inverse function does exist for this function f of x equals x squared, okay? And what we're going to do is we're going to feed in a y value from our original function f of x. So what's going on here is we've got our function machine f and we've got our inverse function f negative 1, okay? Let's say I put in an x value of 2 into my function machine, okay? So my function f is x squared. So it's going to do square of 2. It's going to spit out a 4. Okay. Now what I want to do, okay, so that's this dot point here. We're going to take a y value. So y value here would be 4. We're going to take that y value. We're going to take the value of the function f of x and put it into our inverse function. So we're going to put 4 into here, right? Now, according to what I was just explaining a couple of slides ago, if I put this value into my inverse function, it should spit out the original value that I put into my function. Okay, so it should spit out a 2. And you might say, yeah, okay, fine. What's the problem with that? You just, to undo a square, you do the square root. Well, remember, when you square root something, you actually get a positive and a negative version. Okay. So we could just as easily put negative 2 into here, into our original function. It would have still spit out a value of 4. And then if we put that value of 4 into our inverse function, this inverse function is going to have a hard time figuring out if we're talking about this point or this point. Okay, there are two possible points that you could get out of this. Now functions, they are very simple machines. They take one input, they give you back one output, okay? There's no way for this function to figure out, are you talking about negative 2 or positive 2, okay? So that's why functions have to be one-to-one for an inverse function to exist, okay? An inverse function cannot exist if your function is not one-to-one because there are going to be multiple x values to choose from at the end when you apply your inverse function. Okay, and your inverse function is not going to know which value to choose. All right, and so what you just say is that inverse doesn't exist, and you move on. Okay, or you somehow modify your original function in such a way that an inverse function will exist. Okay, so very important. Only one-to-one functions have an inverse. So what we could do, if you really wanted to, you could restrict the domain of your f of x equals x squared function so that you're only talking about the right half of your parabola, in which case your function would become one-to-one. Your inverse function would know to ignore any negative values that it might spit out because that's not possible, and so it should only spit out the positive 2 if we were to go through this scenario again. Okay, so a function has to be one-to-one in order for an inverse to exist. We'll stop there. Okay, so we've seen what an inverse function is, how it relates to your original function, and the conditions for which an inverse function is able to exist. Okay, I'll see you in the next video.